Okay, we'll make a start. Hi, my name is Lyndsay. I'm an Agile Delivery Consultant. I'm currently working with a consultancy called Equal Experts, and we're helping various teams make software better. Who here likes donuts? Anyone like donuts? Great. Okay, so we're here to talk about continuous delivery, but I thought it would help if we could have a metaphor that we can get our teeth into that relates to continuous delivery. So I need your help in a minute. So we're going to do a live experiment, okay, that's going to see how fast we can deliver some things to the back of the room. Donuts. So we'll start with that one box there. So the idea is to try and get an empty box, if possible, or an empty bag, if possible, to the back of the room as quickly as possible. I'm afraid that side's chocolate, this is just sugar rings, so you can find it out later. So whilst you're hopefully thinking about donuts, let's think about how donuts relate to continuous delivery. So the two key principles, the two key benefits of continuous delivery are firstly that you get fast feedback, and secondly that it reduces risk. So with these donuts, the donuts here and the donuts that are going to the back of the room, we're trying to get fast feedback, trying to get feedback as quickly as possible that this small little thing that, according to Krispy Kreme, they can go from raw ingredients to something in the customer's mouth within about 2 hours. We're trying to get fast feedback, make sure that the thing that we've built, the thing that we've made, is either going to make the customer happy, it's going to make their life better, and more importantly, it's not going to make their life any worse. And we're trying to get feedback on that as quickly as possible. The second key benefit of continuous delivery is reducing risk. Because these donuts are really small, these releases are really small, and there's not much time between the releases, that significantly reduces the chance and the surface area where bugs can creep in to the release that you're putting into production. It's also reducing the risk that you're creating waste. It's making it much harder to put lots and lots of effort into something that's ultimately not going to prove very useful. When I started researching continuous delivery about 10 years ago, two names kept coming up when I put continuous delivery into Google: Etsy and Netflix. They were all people were talking about back then. And I was really intrigued by these two companies. Both of them do continuous delivery really well. They have a staggering amount of deploys every day. But they're very different. They both have a lot of traffic hitting their live servers, but their architecture and their languages are very different. Etsy is a PHP monolith, whereas Netflix are famed for their over 600 microservices. And I was curious about how it was that these two companies were so different, yet both did continuous delivery really well. And then, over the last 5 years, I've worked with two very, very different teams. Again, both of them doing continuous delivery well. Both of them have a significant amount of traffic hitting their live servers. But one was a couple of monoliths, a C++ monolith and a C# monolith. And the other organization had over 300 microservices written in Scala. The other significant difference about these organizations was one was private sector, the other was public sector. So working with these two very, very different teams and having a look at organizations like Netflix and Etsy, I've realized and observed that there are some practices that help teams do continuous delivery well, and some of those practices are universal across architecture and across whether you're a private sector or a public sector, regardless of what kind of language you use. But I've also observed that there are some best practices that are particularly relevant to teams that are building monoliths. There are also some best practices that are particularly relevant to teams that are building microservices. Finally, I've observed that there is no single silver bullet. There's no single recipe that you can follow that will get you to do continuous delivery well. There's no single best architecture, best language. It's a collection of practices. It's a bit like if I produced the best ever recipe for making donuts and I gave it to you all, there'd be quite a degree of variance in terms of how your donuts would turn out. It really would depend on how good a chef you are, I think, and how many years of experience. When I was at school, about 20 years ago in the late 1980s, I was trying to learn French, and it's a typical state school that I was in. So, class of 30, Our French teacher was from Scotland, and we had a textbook from the 1970s. And we had massive amounts of verb tables that we had to learn. And not surprisingly, it was really, really difficult. I found it extremely challenging to learn French that way. What really accelerated my learning of French was when I went to France and lived with a French family, and all we spoke was French. Not only did that get me speaking French very quickly and much better, but also I started thinking in French. And so it is with something like continuous delivery. The foundation for continuous delivery is making cultural changes. And one of the best ways of doing that is to bring experts in that know how to do continuous delivery really well, that speak the language fluently, and they're already living and breathing a continuous delivery culture. And both organizations I've worked in, that's what I've observed, that it makes life so much easier if you can start with experts. So that's the foundational best practice. And the first universal best practice that I've observed is thinking about production all the time. So again, this is a cultural thing that you need to engender in your teams. Thinking about production all the time means that the moment a team is giving a feature or a user story to work on or a bug fix, the first kind of thoughts they have are how do we evolve production behavior to slowly grow towards the end state we need for this feature? What's the smallest change we can make as soon as possible to move to production towards that end state? And most importantly, especially for anyone that's new to continuous delivery, they need to think about every line of code that they commit into source control, whether that line of code is safe to go to production that day. Because the chances are if you're in a continuous delivery environment, it could well do. Another way of thinking about production all the time is by starting thinking about it in your stand-up. So this is a recent stand-up we had at HMRC Digital. And you can see we're gathered around the board. Our board has a done column on the far right. And done for us meant it was in production. Our next column to the left of that was ready for release, ready to release to production. And then it was the standard columns of in QA, ready for QA, in development, etc. So rather than using the normal stand-up format of just going around in a circle and asking the standard 3 questions, we always started on the right. And here in the middle you see Lynn, the guy with the bright trainers, our QA, talking about, firstly, what has been most recently deployed to production? What went to production yesterday? What's about to go to production? Then we talk about what do we need to start thinking about ahead to today? What are our plans to release to production today? Only then do we move to look at what's in QA. And again, we're starting to think about when are we thinking this might hit production? What advanced planning do we need to do to prepare for that release? We then move to in development. Again, thinking ahead to how are we going to get this change as quickly as possible and as small amount of change as possible into production as soon as possible. The second best practice I've observed in both cultures and both teams is making testing an activity instead of a phase. In the private sector organization, when I arrived there, they had just made the transition from doing annual releases to weekly releases. And that was a very, very painful transition. Prior to going to weekly releases, this was their typical development cycle. A product owner would come up with some crazy new idea. He'd give a definition of that to the team. The developers would build it. The testers would test it. And then WebOps would have to deploy it and live with the consequences. The fundamental change they made to this process was making testing an activity that everyone did throughout a feature's life cycle. So when the product owner came up with an idea and brought it to the team together with the product owner would think about what the acceptance criteria were for that change. How would they be able to test it to make sure that what they were building was not only the right thing that the product owner was specifying, but also wasn't going to break production. When the developer starts developing it, they're thinking about testing from the outset. They're thinking about what unit tests they can write, what integration tests they write, and also how they can write acceptance tests to ensure that as much of the end-to-end journey is correct, as well as looking at other changes that might cause production to break. So making sure that as their changes are going into source control and then onto production, that it's not going to break production. This is quite a fundamental shift in how a team thinks about testing, because it frees up the tester to do more exploratory testing, because they're now more confident that because the developers have written more tests around the change and they've thought more as a team about it, they can start exploring things like edge cases and boundary conditions that may not have been tested by the automated tests. This also allows web ops to focus on getting the feature just deployed and making sure that the underlying infrastructure is working correctly. When I started my career about over 20 years ago, I was a graduate. I did aeronautical engineering, and I had the good fortune to go and work on this aircraft. So does anyone know what's special about this aircraft? It's called the Astra Hawk. Has anyone come across it? Okay, so this aircraft was a fly-by-wire aircraft, and they used it to train test pilots, and it could simulate any other type of aircraft. And it was a credible thing to work on when I was about 21. It was very exciting. What was more exciting was we were working on an airbase. We had this kind of thing, Tornadoes, Harriers, and all sorts of other planes and helicopters flying around the whole time, right outside your window. It was a very, very exciting place to be, because I was crazy about planes, as you can imagine. I distinctly remember one day when we heard over the loudspeaker system that the airbase had gone to an emergency state. And this was because we had an airplane coming in that was having to make an emergency landing because it had a problem with its undercarriage. The undercarriage wasn't retracting correctly. Unfortunately, it landed safely and no one was hurt. Then a few months later, each airbase where this particular aircraft was deployed to received a report that did a root cause analysis. It went step by step into what happened during the incident and all the steps that led up to that incident, right down to a particular small mechanical component that was the fault. Now, that was the first time that I'd seen a root cause analysis in action, and it stuck with me ever since. Fast forward about 15, 20 years, and I'm working on a production system. It's not going to kill anyone, but we were having lots and lots of issues when we deployed to production. And so we realized we need to start getting to the root of these issues. So we applied the same kind of root cause analysis using the 5 whys technique. We found this particularly helpful to a monolith because it was such a large beast, it was very hard sometimes when we had a production incident to easily untangle exactly what had led up to that problem. So the steps we went to are, as you see here. Before we got together for the 5 whys session, someone, the facilitator, would write down a timeline of exactly all the events that led up to the incident, then what happened as we were trying to triage the incident and resolve it, and then the steps following it that finally resolved it. We gather everyone together in a room that's been involved in the incident. So this isn't just the developers or the people that fixed it or the web ops people. This is the product owner that specified the change that led up to that problem. It's the support people that received calls or noticed that there was a problem with our production servers. It's the developers involved, the testers, everyone involved in that chain of events that led up to this issue. We go through the timeline to make sure we've all got the same context and cover any missing gaps. And then we ask ourselves, where do we want to start asking why? Where's the best place in this timeline to try and uncover what is the root cause? So we pick an entry point. We agree what is the actual event that's happened here, and we ask, why did that event occur? Then we consider, how could we change our system? What process improvement can we make to try and reduce the likelihood of that event occurring again? And then we go down another level. So we keep doing that 5 times as necessary or more until we get to the root of what caused this issue. If you have a very big team in the room, then it's also useful to try and split the team into sub-teams of 3 or 4. And when you do that, we still found it very useful to keep cross-functional teams. The outcome is a table, as we document it, something like this, which we then share with the other people at the company. And it describes very clearly, step by step, what the event was, why we saw it happen, and what we think we could do to improve it. This approach is really, really useful, particularly when you've got people that are either new to continuous delivery or new to the system and company that you're working in. So it's useful for 2 reasons. Firstly, they get to see the kind of impact that their change has on their production system. They learn so much about how their production system works and reacts to subtle changes. And with that new knowledge, it really affects the way they start coding in the future for developers, and also for testers that are new. It starts making them think about different ways they should be testing changes. By having such a variety of functions in the room, it helps people to learn about their impact on other people in the business. And again, makes them consider their own role and how they're conducting their work a bit differently, because they don't want to cause pain for other people that are in the company. We have used this technique in the microservice organization, I should add, but we've had far fewer production incidents, so it can be relevant to both cases, but I've primarily found it a benefit to monolithic environments. Again, at the monolithic team, we had a real problem with our releases. So every one of our weekly releases, the team were trying to work out what is the risk present in this release. And it's a bit like playing Spot the Difference. Okay, we have the release that's in production, and we have a release candidate. What are the changes that have got into that release? When you have 8 teams all contributing to the same monolith, it's very, very difficult. This is primarily because we had a kind of a semi-automated process for trying to collect together all the changes that were going into each release candidate. So in this picture, there's about 13 differences. Okay, I'm going to give you a minute to see how many of those 13 you can spot. Okay, shall I end your misery now? Has anyone got to 13? You got to 13? Cool, okay, excellent. Right, so there they all are. It took me quite a while to find them myself, and so intriguing. Now, this has been fairly simple for you. It's just 2 pictures. But imagine this for a massive software system, how difficult it would be doing the same thing. So after much pain and angst, the solution that we came up with was not surprising to automate the creation of our release notes. Now, in a software system, the single source of truth for what's changed should be your source control system. And if your software is well partitioned, then you can normally extract a higher level view of your system from the file paths that make up your source control system. And so you can easily see from your source control system, when you do a diff between one version and the next, what lines of code and then what areas have had changes. But that by itself is not much use, because you really need the context as to why those changes have been made. In addition, if you're having people commit code that gets production but may not be ready for actual use and should be behind a feature toggle, you need to know what state each of those changes are in. So the tool that we built took a candidate version number, it went off to production, scraped what version that was at, and then it went to the source control system and essentially asked for all the commits messages between those 2 versions. It then went off to our Agile project management tool. It parsed each of the commit messages, found the ID that related to what story or defect or bug it related to, and pulled out the title, the author, and the state. It then compiled it into a release note, similar to what you see on the right. So the team that were preparing for the release could clearly see that this release candidate has these stories and defects in it. This is the state. These are the ones that are ready for release. These are the ones that are still being tested. These are the ones that are in development, so we really shouldn't see any behavior from them in production. These are the areas of code they've changed. And also, more importantly, these are the people that have worked on it. So if you have further questions, these are the people that you can approach for more detail. The other beauty of this process is that it highlights untracked work. So it shows you where people have been making changes and they haven't recorded what feature or story or defect it relates to. Now, maybe they just forgot to put the commit message in. And maybe that they're making improvements off their own back without really thinking about what they're doing. So it highlights an important area of risk that you can address quite quickly. And this made life so much easier for our release team, because they're very much more easily to focus their time on looking at the risk that was present in each release. So moving on to microservice best practices. So the team that I most recently worked with was HMRC Digital. And this diagram up here, you don't need to read the writing, it's more the layout of it that's important. It shows around the edge all the different tax services that HMRC Digital is building. And then in the middle, there's circles that represent the different platform teams that underpin those services. So HMRC Digital are building new tax services that allow anyone to interact with HMRC in a digital way. We've gone over the last few years from 1 to over 20 teams with 7 platform teams. And across all those teams, we've now got over 300 microservices running on a single platform, a single production environment. So that whole infrastructure, all of our environments are maintained by just 2 WebOps teams, so about 20 people. Now, it's just not feasible for those 20 people to know everything about all of those tax services. So the approach that we've taken is something we stole from Amazon. The Amazon CTO, Werner Vogel, said that you build it, you run it. And that's what we dictate to our teams. If a team builds a microservice and they put it into production, then it's that team that needs to monitor into production. They need to make sure it's performing correctly. And if they see anything wrong with it, they're the ones that need to figure out what's wrong, create a fix, and then get it deployed. Our WebOps team provide the pathway production. They provide the tools and the infrastructure that allow releases to be created very quickly and deployed seamlessly to production. They also provide the tools to very easily monitor production, things like Kibana, Grafana, and also using things like Sensu and PagerDuty to receive alerts on any problems. This approach is what's allowed us to scale from just a small number of teams up to, we have now over 20 teams, 30 teams spread across 5 different locations. Because of the diversity of the tax services that we have at HMRC Digital, it means we're a bit like a village or a small town, that we each have different people or different groups of people doing very different things. We have the equivalent of a fishmonger and a blacksmith, for example. Now, in the early days of our platform, where we had about 5 to 10 teams, we did have some bust-ups. We had instances where one team was trying to get their microservice released, and it depended on some other team's microservice, likely to be one of the platform microservices. And what they were finding was that one team, the platform team, was changing their microservice, and it broke the other team's microservice. And it was causing much frustration because they urgently needed to get their microservice out, but the other team keep changing it. And after much angst and discussion, the teams came up with this great idea. They said, well, what we really need is a dedicated set of environments per team. So they said to the WebOps teams, please can you provide us with dedicated dev and test and pre-production environments for each team. And that will sort all this out, because then we can have a fixed set of other teams' microservices in our own one, and we can just keep changing the one we're testing, and then we'll go to production, everything will be fine. Now, on the face of it, that sounds like a good idea, perhaps. Now, fortunately, our WebOps team saw some problems with that, and they said, no way, we're not doing that. What we need to do is we need to stick with our single set of environments that everyone shares, but you need to care a hell of a lot more about the other teams. You need to care so much that you don't break other teams' stuff. And you do this by keeping your APIs backward compatible. You should note that we don't use any versioning of our internal APIs that these teams are using. So each time we're changing something that another team uses, we've got to make sure it doesn't break what they're depending on. Now, of course, in real life, you are going to have to make breaking changes. Things are going to become very brittle very quickly if you don't. So the way we solve that is we give people plenty of notice. So if you're going to make a breaking change, we'll do an internal blog post, we'll make sure all the teams have sight of it, and we'll tell them what we're changing, why we're changing it, when it's going to hit production, and that normally needs to be at least 4 to 8 weeks off, and then clearly what are the steps that they need to do to change their microservice to migrate onto the new version. And then we need to provide a pathway that allows them to move to the new version before the breaking change is introduced. So I've covered quite a few different practices here. And as I said, there's some practices I've observed that are universal in helping teams improve their continuous delivery. There's some practices that are particularly relevant to monolithic teams. And there's some practices that are more relevant to microservice teams. There are other practices and techniques that I haven't had time to go into today. So if you have any questions or comments or queries, come and chat to me at the end. And I think we've got some time now for some questions. Okay, anyone? Sure.
On that last slide, number 6, I probably missed something. It sounded like you don't keep the APIs back compatible because you don't use version numbers. You make people roll forward.
So your question was whether from what I've described, we don't keep APIs back compatible because we're rolling forward, because we're not using versioning. Right. So, okay, I'll explain that perhaps in a different way. So, if one of the platform teams is an authorization team, and so the services we build are used by all the other teams to make sure people are authorized when they come onto the platform. And so we're in the process, we're often in the process of making changes to the authorization mechanism and making significant improvements to it. Now, what's important is that as we're making those changes, we're still releasing several times a week, but we're releasing in a way, and we're making a change in a way that is not breaking other teams that depend on that each time we do a release. And at some point in the future, we will have to make a change that if everyone hasn't migrated to the new API, then they will break. And we do that by essentially, say, instead of using version, we might introduce a new endpoint that has a new behavior that people might migrate to, whilst we keep the original endpoint in production. And we'll tell people, you can stick with this endpoint until such and such a date, but before then you have to move off. Does that answer your question? Cool. Okay, thanks. What else would people like to know or curious about?
Can I just ask, do each of these microservices have their own database? Or,
Yeah, so you're asking whether each service has their own database. Yes, so each service has their own, we use Mongo in this case, so Mongo collection or set of collections per microservice.
So do you have to worry about things like transactions across microservices?
No, we don't. So your question is, why do we favor not versioning our APIs over versioning them?
Explicit.
Pardon?
Explicit.
Explicitly versioning. I wasn't involved in the decision myself, but from what I've observed, it's just been simpler not to have to agree on a versioning system. It's something that, so we've been working on this system now for over 3 years, and I said we have over 300 microservices running, and it's something that we've never felt there was a compelling need to do it. For our public APIs, we do use versioning, but for our internal ones, we don't. Sure, yeah. I'd have to ask one of our architects the full story on that.
There are other cases where you've had to have like 3 endpoints because you've got 3 versions that people haven't yet migrated off the first one, and you're moving to the third one, and the second one is like the one that's currently being used most, for example.
No. We try and keep things moving forward as quickly as possible. So I think the longest change period we've had was about probably 3 months, where we were making a fairly fundamental security change that was going to affect all requests that go through our platform. So we had to give people about 3 months' notice of that change, and then we introduced a new feature, I think, 1 month in, and then that gave people 2 months to move over to it. What other questions are there?
Can we have the last slide back again to remind us, please? Thanks.
Sure.
So, obviously, two of the things you can't generally do. I mean, you start with the best people you can hire, which is often not the case. You've got to move forward with who you've got. And then the on these who stuff that is in production?
Okay. So I can just rephrase that for everyone else. So you're saying that it's not always practical to hire the best people, and often you have people that perhaps don't know about continuous delivery or not familiar with monitoring production. So how do you combine that with the need for teams to own their own microservices and monitor production? So I've seen that in both places actually. So in the monolithic environments, we're often hiring graduates or people that weren't from a CD background. And one of the approaches we took there to address this problem around monitoring and not really understanding some of the CD principles around it was we formed a virtual release team. So for every release we did, any team that had committed code into that release, they would provide one or two people, either a developer and a QA, into a virtual release team that would get together before the release went to production. And they would, with the web ops team as well, they would start monitoring production. We were using, can't remember which monitoring tools we were using. Oh, yeah, can't remember. Anyway, so they would start monitoring production, and they're on a Skype group. So people were talking about what different messages they were seeing and whether it was something that we needed to worry about. And they would do that for a period of an hour before production, then they would see the release go in and keep monitoring for about an hour afterwards. And then the next day again, they would just check the different monitoring systems for any unexpected behavior. And that process was really, really educational to the people that are in that team, because they very quickly started seeing the kind of like the vital signs of the production system, the kind of the pulse and the heartbeat of our production system. And they quickly saw what impact it had when you did introduce a change. So how did the pattern of all the log messages or the response times change when we put something into production that causes a problem? So that was one technique that we found really useful for educating people about the need to think very carefully about the change they're putting in. At HMRC Digital, what we've done there is we've got tools like Elasticsearch, Kibana and Grafana, but just having those tools means that people don't immediately use them or know how to use them well. So we've had a team set up a set of automated dashboards per microservice per team. So if a team creates a new microservice, they instantly get a set of Kibana and Grafana dashboards that show metrics that they should care about, like response time and the number of requests that are hitting their microservice and the number of errors that are being logged. So these dashboards are ready-made for them. So that gets over the problem of people not knowing how to build the right kind of dashboards or not knowing what metrics are important. That's kind of almost the easy bit. The next bit is to make sure the teams look at these things and then start using them correctly. And that's been a bit of an education process where we've had to find teams that are doing it well and getting them to talk to the other teams about what they're doing well and how they've found it useful. We've also been introducing a concept of runbooks where each team has to document how they support their microservices in production because web ops have clearly stated they are not supporting their microservices. Someone needs to take ownership of their microservices. And so the template that we provided for the runbook talks about what are the microservices that your team own, how do you monitor them, where do you go to check if they're working correctly. Does that help answer your question? Sorry, can I just go to somebody else that hasn't asked?
So on that last point you made, what's the long-term strategy for that? Because obviously this is a migration project of all the services to the web. And if each team that's produced that microservice has to support this microservice, what about the long term? Do you keep that team around forever?
So I guess two parts to my answer. So your question is what's the long-term strategy for something like HMRC for supporting?
If you've got disparate teams that have made it as part of a migration project, so you're putting that returns microservice online. Once that's done, how long do you keep multiple teams?
So probably the official answer is we don't know yet. Okay, but from an equal expert's perspective and my own personal perspective, our preference is that the teams that build the microservice, they need to keep supporting them throughout their lifetime until retirement, and that team should retire it. But once a team has got their service in production and it's stable, they don't need to be the same size as they were when they were building it. So that team could shrink significantly And if possible, that team could shrink so much that it either takes on a new delivery as well, and then just look after the microservices that are in production. But it's a nettle that we haven't really grasped properly, because we've only had a few services get to what's called their live assessment. How are we doing for time? Are we 4 minutes? Okay, so we can take a couple more questions.
Mine's kind of linked to that.
Okay.
You're probably on the GDS, like take funding and review and all those other things. So, because they're set up for a project and the project comes to an end, and then there's a smaller scaled down team that pick it up in terms of the live service, then my question is linked to the previous one. I think about trying to work through where they sit then. Do you have like a generic team that will pick up all the microservices over time?
All right. Sure. Okay. So your question is how, again, in the long term, how do teams that will work on a service, what happens to the service when that team is really no longer necessary in it? Does the service get supported by some central engineering team? So my personal preference, and equal experts would also say with this, that we think there shouldn't be a single support team or a single engineering team. We believe that's a very bad idea because there's little ownership there. But what would be better if a team that might be working on a kind of similar area of features picks up those services. A good example is some improvements to the ability to make payments to HMRC, which is a really important thing for HMRC and the UK government. So we introduced a whole bunch of improvements, and those improvements were done by a dedicated team that was spun up to improve payments. And once they'd done all the various integrations with different payment providers, we didn't really need them as a team. So it was a question of, well, what do we do with all their services? And also, what do we do with the people that are in the team? Now, most of these payments were generally made through something called the business tax account. That was the user journey that people would tend to go through to make these payments. So it was agreed that the payment services would then be looked after by the business tax account team, and there was a knowledge transfer into that team. So it does mean that some teams might suddenly become custodians of services that they didn't originally build. But our preference is that it's not a support team.
Just one more question, really. Are there coding standards across the teams, or is there a similar approach, similar technology,
So your question is, are there coding standards across the team? So at the start we said, yeah, we advocate pair programming, but we try and let the teams be fairly autonomous in how they work. We at the start have dictated that they all use the same tech stack. So everyone uses Scala, we all use Mongo, and we're using things like Docker for our containers. And we also have a set of common libraries that all the teams have to use. Although using libraries in a microservice environment is fraught with danger. So there's a whole other talk I can do on that. So if you have any questions about that, come and have a chat with me later. Does that answer your question? Do we have time for any more questions, or? Okay, one more question if anyone's got one.
Can I just ask, do you host the containers yourself, or do you pay someone else to do it for you?
We have two providers that provide us a hosting platform, but it's our WebOps team that they kind of run all the virtual machines that are hosting Docker. Okay, great. Thank you very much for your time.